So in this lesson, we are going to be dealing with the midpoint of a line segment. So, sharing my other window with you. There we go. All right. Resume share. And I want the chat up. Okay, cool. All right, so midpoint of a line segment. Everyone knows what a line is. What is a line segment? Well, essentially, it's just a piece of a line. It has a finite end on this side and a finite end on that side. So a normal line, so like a linear function, is an infinite line that just keeps on going and going. You can have something called a ray, where it has an infinite, a finite stop on this side, but then keeps on going on the one side. It could go that way, it doesn't matter, but one side has a stop and one side keeps going. And then a line segment, as I said, is where both of them are just stopped there. Now, to calculate the midpoint of a line segment, it's actually very intuitive. So if you think about a number line, for example, let me do a different share for you guys. So if you have a number line, and I tell you that you have the number 8 there, and then the number 12 here. And I say to you, what is the midpoint between these two numbers? Hopefully, most of you will be able to get that. So there's a variety of options of what you could do to find this value. You could add these two numbers together. So 12 plus 8, that gives you 20. And then you divide by 2, and it gives you 10. So for those of you that were thinking 10, well done, it is 10. You could as well say, well, this gap between my values is 4, so half of it would then be 2. So I need this gap to be 2, that gap to be 2, and therefore it's 10 as well. Great. So no one should be dying in their brains because of this. What changes with a midpoint of a line segment is that now you don't only have a horizontal line, your line could actually be diagonal. Well, how do we deal with that? Well, instead of you taking my word for how we deal with it, I'm going to show you a nice little animation on the website, so you don't need to worry about missing it, because you can go back to it at any point. It is in week 13, as you can see, of your foundation course, lesson 42, midpoint of a line segment. And this is the animation.
The midpoint formula. The midpoint formula is used to find the middle point of a line segment. It is simply an average that we are calculating of the x coordinates and then of the y coordinates.
So just as I said, you're calculating an average being in the middle. Just as we did horizontally, we're now going to have to be doing vertically as well.
Think about when you want to calculate your average for a subject at school. You would add all the percentages together and then divide the sum by the number of assessments that you have written. This is provided that the assessments are of equal weighting. The same idea can apply to Cartesian coordinates. If you are given a number line and asked to find the middle between 5 and 15, we can easily see that the answer is 10. How can you get this answer without the use of a diagram? We simply find the average of the values. We would take 5 plus 15, which equals 20. And then we would divide this number by 2, because there are two numbers. This would give us 10. If we now look at the Cartesian plane, we can see that it is simply two number lines, one for the x-axis and one for the y-axis. Therefore, to find the midpoint of 2 points on a Cartesian plane using the midpoint formula, we would find the average of the x coordinates and then of the y coordinates separately. This will determine the middle of the x coordinates and of the y coordinates, arriving at one coordinate, which is the midpoint.
All right. So it is very important to remember that all you're doing is you're averaging twice. So you're averaging the horizontal distances between the 2 points you have, and you're averaging the vertical distance between the 2 points you have. So some of you who have done this section may say, well, that's all very well, but there are some questions I still have no idea how to do. You're saying you just average it. Well, in essence, you do, but it can get slightly more involved, but still only using averages. So let's have a look at a couple questions. Again, remember, if you've got questions throughout my explanations, please just type them in the chat. I do have the chat open and keep an eye on it throughout the lesson. All right, so if we take a very simplistic example, we have, for example, the point 3, 4, and we have the point -1 and 2. And I say to you, calculate the midpoint. Okay, so I'm simply going to be using my midpoint formula. The midpoint formula said it was the average of my x's and then the average of my y's. So we need to be able to identify what's x and what's y in both of these. Doesn't matter if I name this one x1 and this one x2, or if I name this one x2 and this one x1. Well, no, it doesn't. You can use either point as the first point and either point, therefore, as the second point. However, you need to be consistent when it comes to the y's according to what you started with the x's. So if this is x1, this one has to be y1. This cannot be y2 if this is x1. Just as if this is x2, this must be y2. It cannot be y1 if this is x2, because the 2's here and the 1's there refer to the first point and the second point. You cannot have the x of the first point and the y of the second point as a point, because then you're completely mixing your points up. So this, when it comes to this formula, not very serious, because you're still just going to be adding them. If it comes to gradients, however, that is when it becomes very, very important, and you can most definitely get the wrong answer because of it. So if we add our coordinates, so x1 is 3, x2 is -1, so 3 plus -1 over 2, and y1 is 4, so it's 4 plus y2 is 2 over 2. If you're unable to do this in your head, which you hopefully should be able to, you can do this on a calculator. So a plus and a minus together make a minus. So 3 minus 1 gives 2. 2 over 2 gives me 1. 4 plus 2 is 6. 6 over 2 is 3. And therefore, my midpoint between these is 1 and 3. Does that make sense? Well, from 3 to 1, I'm -2. 1 to -1, I'm -2. It's looking good. Just as with y, from 4 to 3, I'm -1. And from 3 to 2, I'm -1. Great. Looking great. So this, again, hopefully you can do, because you're literally just taking the coordinates that were given to you, subbing them with the formula, using a calculator if you can't do it, getting an answer, getting your marks, and being a happy person. What happens if you have a slightly more complicated situation? So let's say, for example, and I'm even going to use the same values, 1, 3, and 3, 4. So my midpoint is given as 1, 3. I give you some other point as 3, 4. And I say, tell me another point where this is the midpoint of. So this gets a little bit more complicated because you're now asked for another point, not the midpoint. So how am I going to use the midpoint formula when the midpoint formula is used to calculate the midpoint? Well, think back. I didn't say that the midpoint formula was used to exclusively calculate the midpoint because we have what we need involved in the formula. So if you write down the formula, our midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. So let's fill in what we know. My midpoint here is 1, 3. Notice this midpoint is a coordinate. It's not just the x part, it's not just the y part, it's the whole coordinate. Because coordinate on the left must equal the coordinate on the right. So x1, doesn't matter which point I make x1? No, it makes absolutely no difference. For a change up, I'm going to make this point 1, I'm going to make that point 2. So therefore, x1 is x, x2 is 3, y1, well, that's y, and y2 is 4. So we filled in what we know, but they're coordinates. It's not like we can take stuff out of a coordinate and move it across the equal sign. Good thought, not going to help. But it is related to what we're going to have to do. As I said to you, the midpoint on the left must equal the midpoint on the right. And for them to be equal, we need to make sure that the x-coordinate on the left equals the x-coordinate on the right, and that the y-coordinate on the left equals the y-coordinate on the right. Which means that we can actually create 2 new equations from this one equation. The first one says 1 is going to equal x plus 3 all over 2, because that must equal this. Well, this equation we can definitely solve. We multiply the 2 up. We take the 3 over, it becomes minus. The x is minus 1. Fantastic news. And even better than that is that's exactly what we got in the previous example. And then if we have a look at the y's, we know that 3 must equal y plus 4 all over 2, because that y coordinate must equal that y coordinate. So again, we multiply the 2 up, we get 6, y plus 4, take the 4 over, becomes a minus, and y is 2. And we're like, wow, that's amazing. That means that this coordinate over here is going to have a y coordinate of 2 and an x coordinate of minus 1. And you're like, that's even more amazing, because that is exactly what it was in our previous example, showing that we can go either direction using this formula. Quite amazing, isn't it? So option 1, you're given 2 points, use midpoint formula to find the midpoint. Option 2, you're given the midpoint and a side, you can use the midpoint formula to find the other side. Okay, still not too bad. Getting a little bit more there, but still not too bad. Well, let's step it up again. What about, and I'm going to take one from the textbook, what about if we have a square? There's my square. And I am able to say that that coordinate over there is B. That one over there is A. That one over there is D. And that one over there is C. And C were given coordinates of 4 and 2. Besides that, we are also given the fact that we have one diagonal over there and one diagonal over there, and we are told that this intersection point is the midpoint, and that is 0, minus 2. And they say to me, find the coordinates of B, of A, and of D. Sure. All right. So what can we actually do? Well, we know that this is a square. So a square means that that distance equals that distance, equals that distance, equals that distance. Okay. Now, if this is the midpoint of 0 and minus 2, I need to find the coordinates of A, and I can use my midpoint formula. Is there maybe a quicker way of doing it? Well, I could do it purely intuitively. And I've already shown you about this. So remember, it's an average. So we can go from 4 to 0. That means we're minusing 4, which means from 0 to whatever the x coordinate here is going to be is also going to be minus 4. So let me use a dark blue for this. So this is some xy coordinate. Well, if we're taking 0 minus 4, that's going to be minus 4. Bam, done. What about if I have a look at the 2? 2 to minus 2 will also minus 4. So minus 2 minus 4, clearly that is going to give me minus 6. Bam, we just found the coordinates of A. Purely through an intuitive method, we see a pattern, there we go. Because that is what an average does. Finds the middle, and you know that the distance from the one side to the middle is equal to the distance of the middle to the other side. So now we've got these. How are we going to find the other coordinates? Well, with this being a square, we know that all of these side lengths are equal. But we don't know how long that is. We know that that will equal that. We could work out that distance and therefore work out those distances. Sounds like a lot of hassle, to be honest. But this is a nice upright square. And if it's a square, it means we have perpendicular angles in the corners. So what color can I use? Let me try a yellow. It should work. So there's a right angle, there's a right angle, there's a right angle, and there's a right angle. And because of those right angles and the perpendicular lines, we automatically know what some of the x and y values are. I know that because this is a horizontal line and that's a vertical line, my horizontal value here is going to be the same y value. It's also going to be minus 6. And I know that my x value here is going to be the same as my x value up here because it's in the same vertical line. Well, that's going to be 4. Bam, I find D. What about B? Well, B is exactly the same. B is going to have the same x value as A because it's in the same vertical line, -4. And B is going to have the y value same as in line with C because it's a horizontal line, and that's 2. And there I found all of my coordinates. All right. So with finding the midpoint, you could now find these lengths if you wanted. You could find the length of the diagonal. You could calculate a gradient. You could do a whole bunch of stuff. But with midpoints, it is always the average. And you can either use a formula or look distance there, done. X, Y, calculated. And this is 100% acceptable. It is always best as well to show working out. So just show some version of 2 minus 4 gives me -2, therefore -2 minus 4 gives me -6. Okay, great. Just that as a marker, we know where you're going. So if you would like to practice this a bit, you have exercise 11.1, page 104, and this is in book 2. You'll see that this one is actually question 4, but you can practice any of the others.